Howdy, and welcome to the second video in abstract classes. If you haven't watched the previous video, I recommend that you do that. This is part 2. And in this part, we are going to make a case for abstract classes. Sometimes strict polymorphism just isn't enough or doesn't quite make sense. So let's talk about how abstract classes can help us. And we're going to start that with a scenario. Let's go back to our project here where we're drawing shapes on a canvas. I'll just run it again to show you what it looks like right now. We're drawing these rectangles on a canvas. We also have this orange one it's in the data, it's called a square. So that's interesting. But I now want to add a circle to this. I want to be able to add circle shapes and not just rectangle shapes. So if I created a new class circle and I added it into the same package in shapes, and I wanted to draw it on the screen, I could hypothetically just add a new array list of circle and call it circles. I mean, assuming that the circle class existed. I could do this, and I could create a new array list for every type of shape that I create. So I could create a new array list of triangles, for example. But the way I would print them would probably be identical to this. And that would mean I'd be repeating this code a bunch of times, and not all of the shapes would necessarily be guaranteed to have this draw function. I mean, we could make sure that it did, but what if somebody 10 years from now decides that they want to add a hexagon and they forget to add this draw function? Then how is it going to be drawn? And if you leave all of these shapes up to their own devices to all be completely independent and different, there's really no guarantee that it's going to work properly. It's going to require a lot of editing. We don't really want to do that. We want to write our code such that we need to edit as little as possible in order to make our code more flexible. So if we wanted to add a circle instead of just a rectangle and a square, we probably only want to modify this function in this class. It would be great if we didn't have to modify anything else. We want to modify as little as possible, because when we modify as little as possible, that means we are introducing as few bugs as possible. We're also doing as little work as possible, which makes us more productive. So we want to add circles, but we don't want to do a ton more work as we add more and more shapes. So it seems like we have this rectangle class. It seems like we need to abstract this a little bit more. So maybe instead of having rectangle be like the top of the chain for our shapes, maybe we need like a shape class that can handle some of this stuff. And then each individual type can handle its own stuff. So I am going to create a new class. I said that we wanted like an idea of shape. And we know that using polymorphism, if instead of this array list type rectangle, we can make an array list of type shape, then we can still print the rectangles or paint the rectangles exactly how we have been, assuming that we follow sort of the similar structure as rectangle. So instead of just calling this an array list of rectangle, we can call it an array list of shape. Let's start there. So I am going to create a new class, and it's going to be called shape, and it's not going to have a superclass. Should I call it shape or closed shape? I think I'm going to call it closed shape because it's just a little bit more specific. You can have shapes that are not closed, and so we're going to talk about this. Okay, I don't want main or constructors. Great. Finish. Okay, so I have a closed shape here. Let's brainstorm some of the things that circles and squares and triangles and rectangles, things that they all have in common. So we want to be able to draw them all. So it needs to have a draw with graphics. We need to have that function. What else do you think a closed shape has? That what do all of the closed shapes have? Well, it probably has a get area because every closed shape is going to have an area. It also has a get perimeter. I'm thinking about the X and Y coordinates that rectangle, circle, and square are going to have. That's going to tell us where we start drawing the rectangle or the circle. But then I'm thinking about a triangle, and a triangle is going to have 3 pairs of XY coordinates and not just one. So I don't think I want to include XY actually in the closed shape class because it's not abstract enough. Not every shape is going to need an XY coordinate because triangles wouldn't. So I think also every closed shape is going to have a color. And it's also, of course, going to have the getters and setters for that. Let's start with this. So this is our closed shape class. We need to have a graphics function, or the draw function that takes the graphics. So that's going to be public. It doesn't return anything, so it's void draw graphics G. Okay, and then we need the get area function, which is public int get area. Oh, wrong brackets. We need a get perimeter function, and we need color. I'm going to put that at the top. I'm going to say probably private int color. And then I'm going to have it make the getters and setters for me. So I'm going to, I right clicked, I'm going to source, generate getters and setters. And I want to do it for color. I'm going to generate that. Okay, so now we have get color, set color. I like my getters and setters to be at the end, and I didn't specify that, so I'm going to move them. All right, so we need to import graphics here. And this shouldn't be an int, should it? Again, if we were in class, y'all would have told me about that. I'm nothing without you. Okay, so we're going to import color here. Should make sure that all of these things are fixed because. Okay, so now I'm going to remove these comments. We have we need to be able to draw, we need to get area, we need to get perimeter, we need to get color. And what we've done is basically write an outline for what this class needs to be. We haven't filled in the details yet, but we know that this is what our closed shape needs to be able to do. So now let's think about how do we fill in these functions? How do we draw a random closed shape? Let's look at what we do in rectangle. In rectangle, we set the color, and then we draw something with the graphics. And in this case, we draw a rectangle specifically. And I know that when we draw a circle, we're going to say draw oval instead of draw rect. So we can't really copy all of this. We could say that we wanted super dot, well, not dot. We could move this possibly to the draw function. So I guess this is something that's general that happens in the draw. I don't know that that's great style, but we'll go with it for now. So in the draw function, we just set the color and assume that child classes are going to do more. Okay, then we need to get area. How do we get the area of a closed shape? The way you get the area of a circle is very different than the way you get the area of a rectangle, which is very different than the way you get the area of a triangle. So I don't think I have answers for how we can implement this function. And I heard that you're never supposed to have a function return a value that's not valid. So I can't just return 0 and I can't return a negative number because those aren't actual valid areas. So I don't know what needs to be put there, and I don't know likewise how to do perimeter, because just like area, this is calculated differently depending on what shape it is. So it's still showing up as an area here, or it's an error here, and that's just weird. So I don't really know how to do that. I'm gonna erase those brackets here because I don't know how to do it at this point. And I told you that I was going to be making a case for abstract classes, and that's what I'm doing right now. So we have this idea of a closed shape. We know that a closed shape it needs to have a draw function, because a rectangle, a square, and a triangle, and a circle, they all need a draw function, and they all need a get area function, and they all need a get perimeter function. They all deal with colors. It's just some of those things, because closed shape is just an idea, it's a category. It's not like a physical, tangible thing. It's an abstract idea. And because of that, there are some things that we're just not able to implement at this point. We know that it needs to have a get area function. We know that it needs to have a draw function, but we don't really know what that's going to look like. So we can just say, I don't know at this point what that's going to look like, but I know that you need to have this function. So to do that, I can just create this closed shape class without filling in that function. You can just say, hey, this function exists. I'm declaring it. I'm just not instantiating it. Similarly to a variable, where you can create a variable like int x, and then you have x equals 7. This is the declaration. This is the instantiation. What we're doing with functions is virtually the same thing. I'm going to say public abstract int get area, and I'm going to add a semicolon. I am declaring that this function is going to exist. Let's see why it's upset with me. Okay. So I'm declaring that this get area function exists. I am not instantiating it yet. So I'm basically saying int x. I'm not giving x a value at this point. I'm not giving the function what's called a body. And this is the body of a function. So I'm saying, nope, not going to supply a body for get area because I can't right now. I don't have enough information. And I can do the same thing for parameter. Abstract. I said perimeter. Okay, so now I have these two abstract functions. I'm saying that closed shape is going to have these functions. I can't figure that out yet. So I'm labeling them abstract. Another thing that I have to do, if I have any abstract functions in a class, then the whole class has to be labeled abstract. So we're going to say public abstract class, closed shape. You can see that my errors went away there. What this means is that this closed shape class has functions in it that have been declared but do not have bodies. So what this gives us is now closed shape is available to be a superclass or somewhere in the chain of inheritance for other shapes in this case. But because it's abstract and because we can't really answer these questions, like these don't have bodies. You know how I say all the time that Java likes to get in your way? They like to prevent you from making mistakes. So Java is going to prevent you from instantiating this class. You cannot ever say new closed shape because Java knows that if these functions were ever called, it doesn't know how to behave. So that is very important. Okay, I also think we said here that we wanted to assume that the child classes are going to do more. So I'm going to say abstract on this one too. I want to make sure that my children are going to render themselves properly. I don't think I have enough information right now to do that. So I'm going to delete the body on that one too. And now we have these abstract methods. We have an abstract class. Let's go back to this PowerPoint. So what I just said is that you can declare an object without defining it. We talked about an int, but here it's an object. We have person p. We know that the type of the variable p is going to be person. We just don't have a value for it yet. It's null. So you can declare a method without defining it by using the abstract keyword. So here we're going to say draw. Notice that the body is missing. So anytime where a method is declared, but you don't have enough information to define it or to add the body of that function, it's called an abstract method. And Java is going to get in your way. Like I said, it's not good to have undefined behaviors. What happens if an undefined method gets called? Java doesn't know, and it's not comfortable with uncertainty, so it's going to get in your way. If a class has one or more abstract methods, the class must also be declared abstract. I already said that. So if you have an abstract method, if you have a method that doesn't have a body, you have to add that abstract keyword to your class declaration. And then if a class is abstract, so if it says public abstract class closed shape, the compiler is going to stand in your way. It's not going to allow any constructors of that class to be called explicitly. So we're never going to say equals new closed shape. The compiler will stand in our way, our code will not compile. So even if a class has 0 abstract methods, I guess this is a separate idea. If a class has no abstract methods in it, even if you have all methods that have bodies, you can still choose to make it abstract. This is kind of rare, but it has roots in the same idea that abstract classes generally represent abstract entities. So these are things that are ideas. They are not necessarily things that should be instantiated. They're not like tangible nouns. They are ideas or categories. So if you have something like that, you can still choose to make it abstract if it models some sort of abstract thing. So maybe the idea is like a mammal class. Like I can't instantiate type mammal, even if I might be able to fill in the functions of mammal type things. So what this does for us, anytime you choose to make a class abstract, it's going to prevent you from calling constructors of that class or instantiating an object where that is the dynamic type. So, in other words, if you have an abstract class, you cannot create instances of that object where the most specific class type or the dynamic class type is an abstract class. You can totally have the declared type be an abstract class. Remember, the declared type is what shows up on the left side of the variable. But on the right side of the equal sign, you can never use an abstract type. This is going to prevent us from having an object with undefined behavior. However, so we know that we can't call constructors, but we may still want to have constructors in the abstract class. And if you remember, anytime an object of a child class is created, the first thing that the constructor is going to do of that child class is it's going to call its parent class, who's going to call its parent class, who's going to call its parent class until it gets up to object. So we may want to have a constructor in that space in our abstract class. Okay. I mentioned this before, object variables of classes that are an abstract type, it can still be the declared type. It can be on the left side of the variable. So here we can say property, we could say closed shape, whatever, that's okay. What we can't do is we can't say property S, assuming that property is our closed shape, equals new property. Can't do that. Okay, let's go back to our code and I'll show you how we can get this abstract class to be in our hierarchy of rectangle. So in rectangle here, public class rectangle, I am going to say extends closed shape. Okay. Let's see, it can't be resolved to a type. Oh, it looks like I put that in the wrong place. Update that. Okay. So our closed shape is now in the right thing. Let's see what, oh, okay, let's look at this. So I had previously set double as the return type of get perimeter and get area. And admittedly, that was just a error on my part. I intended to put int, but I didn't. But I knew that I guess it's possible that an int would be upcasted to a double, so this wouldn't be an issue in the way it worked before. But now, let's look at the error. It's saying that I need to change the return type of get perimeter to int because this get perimeter function is now an override. So I am saying here, get perimeter is a function that's required of closed shapes, but I didn't provide it a body. And here in rectangle, I'm trying to provide it a body, but I just got the return type wrong. So my IDE, this Eclipse, is recognizing that getPerimeter is supposed to be an overridden function because it exists in closed shape and it's abstract, which means the rectangle class must include a body for it. But I just got it wrong, so I'm going to change that to int, just for the compiler's sake and for my sake, so I recognize what I'm doing. I'm going to add the @override attribute on it. I'm going to do the same thing here because I know that getArea is also an override. I'm going to change that to int. Really, I'm just fixing a bug that I had written before. These really should have been ints. Another thing is we have this draw function, and we know that the abstract class that we are inheriting from, this closed shape, it also has the draw function. So I'm going to call that an @override too. This is a good idea, adding the @override tags, because it's just going to add a little bit more checking for you, and it will show you some of the errors that you make. If you don't include them, it's not as clear to the compiler or to the IDE what it is that you're doing. So this just makes everybody on the same page and makes it more clear. You'll get better warnings this way. Okay, so in my rectangle class, I have overridden all of the required things. So now what I can do is, instead of rectangle, I am going to call this closed shape. And I am going to call that closed shape as well. So now, instead of rectangles, I have an array list of closed shapes. Instead of calling this a rectangle, see how I'm just making the code more general? I know I said that I didn't want to modify all of this code, but I am modifying the code now, so I don't ever have to modify it again. I've changed this to closed shape. Ideally, when we run this, looks like it's already running. Let's close it. When I run this, it should be exactly the same. Very anticlimactic. Look, exactly the same. Perfect. Okay. So now let's just make sure again in rectangle that we're not redoing any work. So closed shape, it already has a color. So I don't think in rectangle we should have a color, because color exists in closed shape. We don't need to redefine it in rectangle. So, but we're still accepting color as a parameter because we still need it to create a rectangle, but then we can't set it here. So how is that going to work? And how that's going to work is we are just going to rely on closed shapes version of color. And we want to be able to set that at the time we create a new closed shape object. So I'm going to create a constructor inside a closed shape. I'm going to say public closed shape, and inside I am going to accept a color. And I'm going to say this dot color equals color. Cool. So now I have a constructor where we set the color, everything's good. Inside rectangle, I don't have a this dot color, so I can't do that, but I can call my closed shape constructor. I can say super, and let's see, my super is going to be the direct parent to rectangle. So I'm going to go into closed shape and see what constructor is available. There's one constructor that accepts color. And I'm going to send in color. So now the first line of a constructor is always going to call the super constructor immediately before. Previously, closed shape didn't have a defined constructor, which means it had a no-arg constructor. And that meant that rectangle was calling that function automatically. It's not doing that anymore. So instead, we have to call the constructor that it has defined, which is the one where we need to send in color. So ideally, this hasn't really changed anything. It's just how we are changing the color variable. We're calling a constructor that does that. And the constructor does it here. Let's save that. Now, let's see why it's still unhappy. Oh, I just needed to save. Okay, so now I have this function here where I need to set the color, and I can't access the color variable directly because if you see, I have this saved as private. If I changed it to protected, then Rectangle would be able to see it, and I can just reference it like a variable. But I don't want to do that right now because I want to show you what it looks like when all of the variables are private. So instead of just color here, I know that I can get the color. So I'm just going to call get color. Okay, so I believe, nope, we still have one more error. Looks like we still have these functions, and since we don't have this class and our parent has those functions, we can just delete them. We don't need them anymore. Because this get color that we're calling here is coming from the closed shape class. We've defined get color here. Rectangle is going to have everything inside it that closed shape does, and it's going to have more. It has all of this other stuff. So in that way, we don't need to define another get color function. Likewise, since square extends rectangle, square is also going to have closed shape as a parent. Okay, so here we have closed shape. I'm going to run it again, and really all we've done at this point is refactor, so it should be very boring. It should just look exactly the same. If it looks exactly the same, then we've done our job right. And there we go. It looks exactly the same. Super boring. Great. Now I said we wanted to add a circle. So I am going to do that now. I'm going to say File, New, Class. It's going to be in Shapes. It's going to be called Circle. The superclass is going to be Closed Shape. And I want it to create a constructor for me and add the inherited abstract methods. So you can see when I did that, what it created for me was it said that whatever constructor I make, it needs to provide a color because my parent requires a color. So we can add more parameters to that. That's totally fine. We can even remove color if we want to set this as a some sort of specific color that we have stored. But this is a good place to start, so it's created that for me. It has also added the functions that are required to exist if this was a closed shape class. We need to include these. So here, inside the draw function, I know, let's look at how we did it in rectangle. Oh, we're back in circle. Okay, so here what we need to do is we need to change the color, and then we need to draw the rectangle. I said this was going to be an oval, and we need to send in like the X, Y, width, and height are all correct. So let's say for a circle, what we need is we need an int x, an int y, maybe a radius. Okay, and so that means that those are probably things that we need to have saved in this class. We need to have private int x, private int y, private int radius. And then inside our constructor, we need to have not int. This dot x equals x, this dot y equals y, and this dot radius equals radius. Okay, so now we know that our object here, our circle, is going to have these specific variables. Excuse me, I just want to prevent any other notifications from coming on. Okay. So this is what our class looks like. We have the radius. Let's go back to our draw function, which is what spurred all of these things that we would need. We need to provide a width and a height for the circle. And the width of the circle is going to be 2 times the radius. So I'm going to say 2 times radius. And in height, I am going to say 2 times radius. And that should draw our oval. How do we get the area of a circle? I believe that is something I don't really know right now off the top of my head. So I'm going to leave it at 0 because we're not really using it. I believe perimeter is 2 pi r. So 2 times math.pi times radius. And I'm going to turn that into an int. And it's not going to like that. Didn't I already do that? No. Okay. I just didn't put parentheses around it. Cool. Okay. So all of that is fine. I'm intentionally not filling this out. Okay. I'm just going to return 0 there. Forgive that. Okay. So here I have circle. We've got the ability to draw it. We have in X and Y. We don't have getters and setters for these. We're not using them, but it's good practice anyway. So I'm going to generate them. I want all 3 of them. I want it to be at the end because that's where I like them. And now I have my getters and setters. I have a circle. Cool. Now, because we made those changes to shape canvas, I should be able to add a circle really easily. So I'm going to say shapes.add new circle, and I'm going to give it 50, 95, 30. So this is going to be a pretty small circle, and it's going to be color dot blue. Okay, add a semicolon. Ideally, now this is going to draw us a circle. It did. Look, we have the blue circle right there. Now, so by creating, let's review what we did here. In this video, we created a closed shape class. We said that the class is abstract because we don't have all of the information yet to fill it out. We have made it abstract. Inside an abstract class, you're allowed to have abstract functions. Those are functions that don't have bodies, and you generally create those when you know, I want to be able to call a draw function on my closed shape. Every closed shape should be able to draw itself, but I just don't know there isn't a general way to draw it. Just like every mammal is going to eat somehow, but every mammal is probably going to eat slightly differently. So a mammal could have an eat function. It just couldn't be defined in mammal. It couldn't be, yeah, it can be declared in mammal, but it couldn't be defined. So similarly for get area and get perimeter, we know that those are things that closed shape should be able to do. We just can't, we don't have a general way of computing that. So we created this closed shape class so that in our shape canvas, we were able to just say, okay, I have a list of these shapes. And at some point, I want to draw all of these shapes. See how simple and clean this is? We want to be able to draw all of these shapes, but in closed shape, we don't have all of the information we need. So when we extend closed shape, so rectangle extends closed shape, what that does is it says, I am going to fulfill the promises made in closed shape. Anytime you have an abstract method, you can think of it like a promise. For some reason, I think of it like there's some genie in a bottle and I have made a promise to that genie that my ancestors, so closed shapes ancestors, are going to implement this method. And in return for that promise, because closed shape can't do it itself, it's saying, I need my ancestors to do it for me. The genie says, okay, well then you cannot be instantiated. And then, so now we're to the ancestor here, who's rectangle, who has this promise from its, I should say the descendant. So rectangle is the descendant, closed shape is the ancestor, and rectangle has to fulfill its ancestor's promises, or it is also not able to be instantiated. So here rectangle decided, okay, I'll fulfill the promises and I will implement these functions that I'm required to. These are the promises that my ancestor made that I will fulfill. In the ancestor class, these are the things that cannot be fulfilled. Another thing that we did in this video was we created a new class that extends from closed shape that is not a rectangle or a descendant of rectangle. And we showed how you could very easily extend closed shape and use the things included in that to allow us to really draw things really easily on the shape canvas. One more thing that I'd like to mention that I haven't at this point is, let's say we had another class between closed shape and rectangle. Let's say instead of directly going from rectangle to closed shape, maybe we had another abstraction in there. Maybe we had like four-sided closed shape or something like that. So in that way, we might not have exactly a width and the height. We might actually have 4 points. So this stuff that's specific to rectangle, we know that we might want it to have 4 points, but then we could be able to do diamonds and rhombuses and other things as well. So if we wanted to add another abstraction layer there, but if we had that four-shaped or four-sided shape, we still don't have the information on how to draw it or how to get the perimeter or get the area. So that could still also be an abstract class. What I'm trying to say is here, closed shape is the one who made the deal with the genie, right? It made the deal with the genie and said, I promise that my descendants are going to fulfill these functions. But closed shape does not promise that its direct descendant is going to fulfill those promises. It is possible that your descendant's descendant is going to fulfill those properties. And if, let's say, we have another descendant, the closed shape, or the four-sided shape, that extends closed shape, and then rectangle extends four-sided shape. It is possible for four-sided shape to also be abstract. So it has these choices. If it is an ancestor or if it's a descendant of closed shape, it can either fulfill the promises or it can call itself abstract too, which means that it also cannot be instantiated. So those are the two choices that I hadn't mentioned before. Okay, that is the end of this video. In the next one, we're going to do some quick exercises. So stay tuned for that. Thanks, team.